Hello everyone, welcome to Shiv's classes. In today's lecture, we are going to discuss two of the problems which are of JEE level. So, if you are preparing for IIT JEE exam, main or advanced, you would find these problems helpful. So, these questions were asked by one student who is appearing for IIT JEE exam, and in one of his test series, these two questions were asked, and he had trouble understanding the question and solving it. So I am just taking up these two examples to explain you how to approach these problems if you are faced with such kind of problems in the future. Alright, so let's start with this first problem. So the first problem talks about that an expression is given that sine to the power 6 theta plus cos to the power 6 theta plus k into cos square 2 theta equals to 1. So we need to find the value of k in such case so that this expression becomes 1. So what we need to do over here is that we need to find the value of k, and then there are four options given. So whenever you are faced with such problem, what you need to do is you need to remember one entity which is called sine square theta plus cos square theta equals to 1. Alright. So if something is given like this and it is becoming 1, then you would know that it has to become to come in this form itself. Alright. So first thing first, and then second thing is now you need to reduce cos square 2 theta into some form. So you know cos 2 theta is what? Cos 2 theta is cos square theta minus sine square theta. Alright. So you can see that there is again some expression in terms of cos theta and sin theta, and then there is a term multiplied to it, and moreover this is again it's cos square 2 theta. If you do the cos square 2 theta of it, what you will be getting here is this is nothing but cos square theta minus sin square theta's whole square. Alright, okay, and once you try to solve it, so basically you can do two things, right? What you can do over here is either you can work it like this, alright, or you can think of something else as well. So let's stop here with this expression and let's assume that we are taking sine square theta as A and cos square theta as B, right? So let's see what this expression becomes. So this expression becomes A cube plus B cube plus K into, this is some form of AB, right? And if I am putting it in this form, right? So this is my gonna be A minus B kind of a whole square, right? Why? Because cos square theta is A and sin square theta is B. So this is gonna be my A minus B, and this is gonna be my square, right? And this is the expression. Now you also know that what is A plus B whole cube? A plus B whole cube is nothing but A cube plus B cube plus 3AB, and then you are having what? You are having A plus B, right? Now, can you think of putting it in this term also? So either put it in this or just keep it as cos square 2 theta itself. Just not try to work it out any which way. So we'll put it as cos square 2 theta itself and not work on anything else. Now, in terms of this, this is gonna be my AQ plus BQ, and then this is gonna be my expression. If I put something like this is my A is my sine theta, so this is my sine square theta whole square plus cos square theta whole square plus 3 into sine square theta cos square theta, and then this is A plus B, this is nothing but sine square theta plus cos square theta. Alright. Now compare this expression with this one, right? This, now what will A plus B whole cube become? So let's put it again over here. This will become my sine to the power 6 theta plus cos to the power 6 theta plus 3 times sine square theta cos square theta, and then into sine square theta plus cos square theta, right? And why did I do that? Because a plus b whole cube is nothing but sin square theta plus cos square theta whole cube, right? Sin square theta plus cos square theta is nothing but 1. We know that, right? As I said. So 1 cube will become 1. So we need to make this expression like this: sin square theta plus cos square theta, 3 sin square theta, cos square theta, sin square theta plus cos square. This is also 1, you know, right? This is also 1. Now what we are left with? We are left with 3 sin square theta cos square theta term, right? And when you compare this with this, one of these ones, right? You can as well write this as cos square theta. You can write it as. So one thing which you got to remember here is what here is 3. No other expression has got 3. So looks like this is one of the expression which we can work with. And so now let's put it back and see that what will k into cos square 2 theta will become, if this being the case. So k into cos square theta is nothing but k 3 by 4 into tan square 2 theta. Tan square theta is nothing but sin square theta, sin square 2 theta divided by cos square 2 theta, alright, into cos square 2 theta. So cos square 2 theta, cos square 2 theta would cancel out, right? And now your 3 by 4 and sin 2 theta is nothing but 2 sin theta into cos theta whole square, right? Now this will become your 3 by 4 into 4 times sin square theta into cos square theta. 4 will cancel out and this will become 3 sin square theta into cos square theta, which is what we wanted to have here, right? 3 sin square theta into cos square theta. So you can see that my D is gonna be the option for this, right? So D is the correct option. And while we are trying to solve it, we started with the assumption that this form has to come in terms of sin square theta plus cos square theta, right? And when we knew that this expression has to become sin square theta plus cos square theta, we knew that we have to put sin square theta into some form so that this expression will become a plus b whole cube, right? So this is how you have to approach such problem. You have to look at the problem. You know that what is this expression gonna be. You start with that assumption first, that if this expression has to become 1, then it is gonna be something with respect to sin square theta plus cos square theta equals to 1. And then you start working backwards. Then you know that okay, it's gonna be in terms of AQ plus BQ form. When it is in terms of AQ plus BQ form, then you know that it has to be in A plus B whole cube form. And that is how you come to this realization that this is nothing but A plus B whole cube. And then when you put back the expression, you realize that okay, this is the one, D is the only option which is gonna satisfy this equation. Alright. So sometimes you have to work with the solutions, with the options to arrive at the right solution, right? You could have just worked with cos 2 theta and then you would have landed nowhere, because you have to again expand cos square theta minus sin square theta, as I started as well myself, right? But then halfway through I realized that this is gonna be a lengthy process, and since you are working on a problem which is objective, you have to work smartly and then work with the options as well. Alright, hope this part is clear. If not, then please ask me in the comment section below and I'll be happy to answer. Alright, now going to the second question. Second question is again a trigonometric question, and it is asking that there is a big expression given. This is 2 sin square theta plus cos theta plus alpha into sin alpha sin theta and in plus cos 2 alpha plus theta, and we have to find out whether the expression becomes cos theta plus cos alpha, or it is independent of theta, or whether it is independent of alpha or none of this. So in such questions, what you got to do is you got to solve it anyhow. I mean, there is nothing there to work with. So options are there, but if you solve it, maybe you can get some solution. So let's start with the problem. So we have got what? We have got 2 sin square theta plus 4 cos theta plus alpha into sin alpha into sin theta and then cos of 2 alpha plus theta. Okay, when you look at this expression, there is some sort of clue you are getting. You are getting that somewhat oddly there is a 4 over here, and then there is a cos theta plus alpha, and this cos 2 alpha plus theta is as well there over here. So we know that what is cos 2 theta. Cos 2 theta in terms of cos theta form is, we have 2 cos square theta minus 1. Alright, now you can see here this is cos 2 alpha plus theta. So cos 2 alpha plus theta will become what? It will become 2 of cos of theta plus alpha and then square and minus 1. Alright, so here there is again cos theta plus alpha is there, and then we can take out something common, and then maybe we'll left with 2 sin alpha sin theta, which will again reduce to some other thing which we will figure out later. But this minus 1 which is there can be clubbed with 2 sin square theta as well, and so it is looking like this is gonna be the right approach. So let's try to expand it little further, and what we are getting with it 2 sin square theta here plus 4 of cos of theta plus alpha into sin of alpha into sin of theta, and this is nothing but 2 of cos square theta plus alpha and minus 1. Alright, so put 2 sin square theta minus 1 together. So you will also know that what is cos 2 theta. Cos 2 theta is nothing but 1 minus 2 sin square theta as well, right? So in this case 2 sin square theta minus 1 would will become what? 2 sin square theta minus 1 would become minus of cos 2 theta. So let's put that there. So clubbing these two together, 2 sin square theta and minus 1, we will put it as minus of cos 2 theta. Now here 4 cos theta plus alpha and 2 cos square theta plus alpha will take 2 cos theta plus alpha common. So we are left with what? We are left with 2 of sin of alpha sin of theta, and then there is another one cos theta plus alpha as well, because this is what is left, right? Now look at cos theta plus alpha, or rather look at 2 sin alpha sin theta, right? You also know there is this expression which we had derived, but let's do it again. So we know that cos a plus b is nothing but cos a into cos b minus sin a into sin b, and we also know that cos of a minus b is nothing but cos a into cos b plus sin a into sin b. So if you add both of these together, what you will get is subtract cos a minus b minus of cos a plus b. You will get what? You will get nothing but 2 of sin of a into sin of b. So what we have done is, this is the derivation which we have done in our 12th standard book, but I am just doing it over here. So you are subtracting a cos a minus b minus cos a plus b. So you are subtracting cos a plus b from this one. So this expression sin a into sin b plus sin a into sin b, and this cos a and cos b will cancel out. And since this is minus, this will become minus minus plus. So that is why this will become 2 sin a into sin b. So this is compared with 2 sin alpha sin theta. So what this has become is, now you can write minus cos of 2 theta plus 2 of cos theta plus alpha, and you can write 2 sin alpha sin theta as cos of alpha minus theta minus cos of theta plus alpha plus cos of theta plus alpha, and you can see that cos theta plus alpha gets cancelled out. So now you are again left with minus cos of 2 theta plus 2 cos of theta plus alpha into cos alpha minus theta. Now again compare this expression. Now if you say that you are going to add cos a minus b to cos a plus b, so what I am saying here is, if you are going to add cos a plus b to cos a minus b, you will get what? You will get 2 cos a into cos b, because the negative term sin a sin b will cancel out. So here if you compare this expression, call this call this A and call this B, then what you will get? Cos A plus B, right? So you will get minus cos of 2 theta plus cos of A plus B, basically 3 theta plus alpha minus theta, right? Plus cos A minus B, which is nothing but cos theta plus alpha minus alpha plus theta, because this is gonna be my B, this is A minus B. Now this will come to minus cos of 2 theta plus this theta cancels out, so this is cos of 2 alpha, and here alpha cancels out, so this is nothing but cos of 2 theta, right? Now cos 2 theta cancels out, so we are left with cos of 2 alpha, right? Now this expression is reduced to some form of cos 2 alpha, so which is not having theta at all, so this is independent of theta, so this is gonna be my answer, this is gonna be independent of theta, alright. So in this question the clues were that this is odd looking term with 4 cos theta plus alpha, this is cos 2 alpha plus theta, so looks like if I reduce it to 2 cos square theta plus alpha, something will come out as common, and this 2 sin square theta will club with something. So we start using this expression first, which is cos 2 alpha plus theta, and then reduce it further and further, and as we go along we see that things are getting cancelled out and we are left with only cos 2 alpha at the end, alright. So in such questions, when it is given like independent of theta, independent of alpha, something like that, it means that when you try to solve these questions, such kind of questions, something will eventually cancel out and you will be left with some expression either in terms of theta or alpha. We could have landed with cos theta plus alpha as well, which anyways which we didn't know, we had to solve it to get to that, right? So these were two questions which were of certain difficulty level, and I wanted to just solve these questions so that if anyone who is preparing for JEE could get some idea and then start preparing well. Alright. If you have any questions, please ask me in the comment section below and I'll be happy to answer. Thank you very much for watching this video.